Good evening, everyone. Welcome to this session by WiT, and I thank the hosts for inviting me to speak about research as a career option. For the next hour or so, I will, talk about what it takes to be in the field of research and innovation. And if you're thinking of opting this as a career, what does it take? How can you succeed in this format? So let me just put up the slides for you, and then we can get going. All right, so I hope my screen is visible to everybody. As I mentioned, we'll be talking about research and innovation as a career option. Before that, a quick introduction to myself. My name is Piyush Gupta. I'm a distinguished engineer and senior director. I head the research and innovation function at Optum Global Solutions. My program charter is to lead the R&D related activities around emerging tech, around stuff that is new and fancy, and see if it works. And if it works, then how can I bring it into the fold of the organization's technology stack? Along with that, I also head the intellectual property program, which includes patenting, etc., from India, which is part of the larger enterprise-wide program that is run all across our organization. I have about 20 plus years of experience. Most of it has coursed through the research organizations or research departments of my previous companies. I have been with Walmart Labs. I have been with GE Healthcare, ST Microelectronics, to name a few. My area of expertise is software architecture. But having said that, and being part of the research groups or teams, I have had the fortune to play with the latest and the greatest stuff that has been coming out in the industry, and some of them are mentioned here: virtual assistants, blockchain, augmented reality, virtual reality. So anything that's new and fancy. I have a few interests that are visible on the screen. Do a lot of reading. I love gaming, sci-fi buff, among other things. All right, moving on. Let's look at our organization for a minute. So we are part of Optum Global, or Optum is part of United Health Group. It is ranked 7th on the Fortune 500 index. As you can see, our numbers are fairly large, $242 billion in revenue. That was the 2019 numbers. And Optum alone, as part of that 242, is at 113 billion. Now, our mission, as you can see, is helping people live healthier lives and helping make the healthcare system work better for everyone. And given our size, our the area of opportunities or the areas we work in, it uniquely positions us to make that mission true. We are with the amount of data that we have, with the amount of analytics that we can perform on the data, we can actually deliver on the promise of making the health system work better for everybody. Now, with our large footprint, because we are the largest player in this space, we are able to cover every aspect of the member's journey, and the member is nobody else other than the patient himself, right from the time an ailment is identified till recovery and all of that stuff. We have all of those phases, and we can address those. Along with that, with UHC, which is our sister concern and addresses the health insurance business, we are well aware of the members' insurance plans and all of that stuff. And all of that information can be put together to provide an enriched experience to the member overall. Along with that, we also work with the providers, the doctors or the clinics, if you will, the hospitals, and the state and the central governments in United States to address various issues of healthcare overall. Okay, with that, I will move on, and let's start. So, today's discussion, I wanted to break it up into two parts. First thing I wanted to show you, as I mentioned, I lead the research and innovation function. I wanted to show what the team has been up to for the last few years. So I've been with Optum for 7 years, and I've led the team from start. And what you see on the slide are some of the things year-wise that we have worked on. Obviously, we have done a lot more, but these are some of the highlights. And before I jump into the list that you see here, there's something I want to call out. The team that I lead or I execute is involved in something what I like to call as applied research. Now, what does that mean? So we are not doing theoretical or academic research that goes on in universities, because that has its own role to play. and that has its own importance. However, keep in mind from an organization slash corporate perspective, applied research makes a lot more sense. Now, what is applied research? Applied research, in my view, is something where you have to play around with technology, you have to understand how technology works, and then you have to make it work for your organization, your domain, your problem statement. And a classical example of that is blockchain, right? When blockchain came, everybody thought that it could solve pretty much everything. There were use cases abound of what blockchain will do. It'll solve, it'll probably solve world hunger for that matter. Over a period of time, people have figured out that while the tech works, it has certain nuances, it has some challenges. Besides the space of finance or cryptocurrencies and some other areas, blockchain is yet to meet its promise in the space of other domains. Though the effort is not, it has not gone away, it is still happening. So that's what I mean by applied research, that you actually try to solve a realistic problem instead of doing academic or theoretical research, which is anyways happening in universities. Now, with that out of the way, let's take a look at this timeline that I have here for you that I've put up. And these are real things that we have solved. And as time progressed, so 2014, 2015, you see Hadoop or big data was a big thing. Anybody and everybody was talking about big data. Data is the new oil. Data will solve this. Data will solve that. And distributed computing at large was a big factor. Hadoop at that point was the technology of choice. If you're not solving a problem using Hadoop, you're doing something wrong. And we played around with Hadoop quite a bit as well. In fact, out of our work that we did on Hadoop, we actually came up with something which was patentable, and that is the second bullet or third bullet that you see on the leftmost column. That we were able to come up with a execution time prediction engine, which at that point was nowhere. Nobody had done that stuff, and it was novel, it was new, and we were able to file for a patent for that. Other things that you see, the de-identification as a service, web analytics. So the point here is these were actual real problems that the organization and corporation was facing. They were challenging problems. They were not simple to solve. They probably still aren't simple to solve, I would dare say, but they required enough amount of time and research required, and that's why they fall into this category that, hey, you need to do something about this. We don't know how to solve these problems, but somebody needs to do it, right? Moving on, 2016, I talked about blockchain, but we were one of the first teams to play around with blockchain. We created some proof of concepts. We tried to see how the tech works. It was early and very nascent at that stage. We were playing around with different libraries, and different libraries gave different capabilities. Some couldn't do something, others couldn't do something else. So the effect of that R&D was that we were able to come up with a recommendation that it will work, but it'll work this much with this thing, it will work that much with that thing. So kind of a reference for other teams, other groups to take out from. And then they don't have to spend that time doing it. They go ahead and actually apply it if it works for them. At that time, we also started playing around with machine learning. Usually, you see social media sentiment analysis on the list here. MySQL's high availability analysis. This was an interesting problem. We were asked to see if everybody uses Oracle as a database, and there was this ask that can MySQL as a database server give the same kind of high availability capability that Oracle today provides. So we actually set up clusters, we brought down the machines, try to see if the system is available, is it still serving high traffic, high volume traffic scenarios, so on and so forth, and what are the outcomes. So again, I keep going back to the point that these are all applied research problems, that they actually solve a real problem instead of a theoretical problem. Moving on to 2017, very interesting year. We jumped onto the bandwagon of AI big time, and we started fiddling around with chatbots or virtual assistants. And we actually built the first, I won't call it intelligent, but somewhat smart digital assistant. We called it ADA, Artificially Intelligent Digital Assistant. This was for one of our businesses where today members call in and they ask, how does am I covered for back pain, right? They're asking from their policy. And then our agent or our help executive looks up their policy documents, looks up their plan, while the member is waiting on the phone. And it takes good 15 to 20 minutes to respond to that question. You have to go through various documents, you have to go to various websites and applications, and then figure out the answer and then relay it back to the member. What we did was we created a virtual assistant which would try to understand that question and do all this heavy lifting of going through all these data sources to figure out the answer and respond back. Initially, it was the intent was that it would be based, the outcome would be shown to the agent, and then agent will relay still back to the member. But the intent was to speed up, to fasten, whole process, and the member has to wait less. So a win-win for everybody. Open source contribution. Now, this is very important because, again, from an applied research perspective, a lot of time the stuff that we do can lead to something that is new, that is inventive. And this happened when we were playing around with Elasticsearch, which is one of the leading open source search engines in the world. And we realized that the way we were using Elasticsearch, a lot of other people would also be using it. But Elasticsearch did not provide that capability out of the box. You had to write code on top of it. And then we wrote a fairly substantial amount of piece of code that we then contributed back to Elasticsearch. So the team's work was inventive, it was novel, it was new, and as I said, it was not there in the system. And by our contribution, it went back so the others could use it as well. So again, falls in the space of applied research. A lot of other stuff here, and probably I won't go through all. Moving on, 2018, 2019, virtual assistant carried on, and all the research that we had done in 2017 had gone in when it went into production in 2018 and 19. And now, as I speak to you, this is live. It is helping agents when they're receiving calls. And out of the work we did there, a couple of patents came out. You see word sense disambiguation, you see contextual search ranking. All of this kind of came out while we were working on the data for this virtual assistant, because we realized that we have some algorithms here that are completely novel, completely new, and they have been since filed. So as you can see, that while our target or intent was applied research, we did end up doing some portion of it, which you can call theoretical or academic research, but still has practical applications. Because coming up with new algorithms can very easily fall in the realm of academic/theoretical research. So it's very hard to draw a very hard line between the two, but there is clear distinction, and you should all be aware of that. Okay, now with that, I will move on. And what I want to do is that as a career option, if you are looking to move into this space, what does it take? What are the challenges? What are the pitfalls? Because there are a few. It looks like a very glamorous, very exciting career option. In fact, over the years, whenever I meet somebody and I tell them, hey, I lead research innovation, most of the times, first thing I hear is, I have done research, right? And then I start talking to them, and it kind of falls into research. More often than not, it does not. So as I said, it's something that everybody wants to do, but it's not everybody's cup of tea. And I would like to go through some key factors that I think are very, very important for this career option, that if you want to take this up in future, would help you. So with that, first one, adaptability. Now, and the way I'm going to talk about this is the way when I'm looking for candidates, when I'm looking for potential research engineers, what do I look for them? This is the first factor, adaptability right here. The nature of the beast is such that you have to be able to pivot from one problem area or technology to another very, very quickly. It has happened that we started work on something today, which is a Monday, and the team started, everybody's heads down, digging deep, looking into what can be done, how can it be done, whether it is possible or not. All of that stuff is going on, and 10 days down the line, stop, right? And then we switch over to another tech or another approach of solving the problem. And all the work that you did in the last 10 days is Maybe useful, maybe not useful. It's a complete throwaway. It can be any number of things. The point here is, are you adaptable to that? Are you flexible to change your track and then get on to the next track and then do the same thing all over again with the same zeal, with the same effort, and don't feel bad about it, right? Um, be able to start and stop at a fast pace. And that's what I meant. I just gave an example that you started something today, you had to stop something 10 days down the line, and then you have to start all over again. Now our timelines don't generally change. Timelines are still the same because the customer is, or the stakeholder who has asked you to do this is still looking for an answer for you to solve the problem. So we still have to meet those timelines. And obviously, there is some leeway because research is a little bit open-ended and some negotiation is feasible. But we would still like to, we can't take infinitely long. We can't say, hey, keep waiting till we find an answer, because that may not ever happen. But keep in mind, and that's an important aspect, that outcome of research can be negative as well. And that's one of the things that I always talk about with my stakeholders, that look, this is a new problem. We don't know how to solve it. We're going to attempt it. There's a chance that we'll have a positive outcome, but there can be a negative outcome as well, right? And that also plays into this part here, that you're doing something, you figure out there's not going to work out, stop it, move on to the next thing, figure out a different way of solving the problem. So are you able to pivot from one problem to another, or one technology to other very, very quickly? And that's where adaptability is absolutely key. Moving on, emotional flexibility. Now, this one is really challenging and very, very important, because I've seen this happen with a lot of engineers, that I worked 3 months, I worked 6 months on something, and now you're asking me to give it away. Of course, I'm asking you to give it away, because at the end of the day, you're doing R&D for someone else. The problem comes to us because they can't solve it, and they can't solve it not because they don't know how to. There can be any number of reasons, right? Most product teams have a schedule. They have their project timelines. They don't have time. Sometimes they're short on budget. At times, they may not have the skill sets. They know how to solve the problem, but they don't have the right people, right? Their engineers are experts in Java, where let's say the problem requires you to do something in .NET, for example. I'm just taking an example, right? Or it's a SQL problem, but their application is on SQL. The solution requires a NoSQL kind of an approach. Again, you don't have the right resources, and that's why it's a research problem. So n number of things. The point is, when it comes to the research team, we do whatever we have to do. We look into that new tech, and more often than not, it is something that you have not worked on before. So you're researching, you're spending time figuring it out, and then once you're done with it, you have to give it out. And then it is that person's choice whether to implement it or not, and I'll come to that aspect a little bit later. The question is, can you let it go, right? Do you get emotionally attached to your work that you're like, hey, I spent so much time on this, you're asking me to just give it away. That's very difficult for me. I want to take it to production. I want to do this. I want to do that. It is not the right thing to do, not in this space, because the way the whole setup is, more often than not, you will see stuff which will be given away. Second problem on the slide that you see here is, most of the work we do will become shelfware. Again, nature of the beast, that is how R&D works. A lot of stuff that we do, and what I actually showed you on those slides back there, even though they were actual business problems that the corporate is facing or the organization is facing, quite a number of times when we delivered the solution, or the whatever we had designed or researched, whatever was the outcome, while the business did take it, it did not see light of the day for n number of reasons. Now, these reasons are beyond the control of the research team. As a research engineer, you can only influence. You can show that this works. It works in this way. This is going to solve the problem this way. It has these benefits. It has these shortcomings. All of those aspects. But whether this will be implemented or not is in the hands of somebody else. And as I'm calling out, good number of times you will find, and this good number of times is more than 50%. So basically what I'm saying is, more than half of the work that you do will go nowhere, right? Nothing wrong with it. And that's the point I have here. Can you take the moral high ground and realize what you learned in the process? Right? The problem was a challenging problem. That is why it came to you in the first place. That's why it was a research problem. Others could not solve it. Others did not have time to solve it. It was a problem or a technology which nobody had worked on before, and that's why it landed into the bucket of research. So if you were able to solve it, or you are going to solve it, you have probably learned that tech. You have learned how to do something new, which more often than not, others don't know how to, right? Is that learning your takeaway from the whole thing? And that is where emotional flexibility comes into play, and becomes a big part of how you can make it beneficial for yourself, make it a learning for yourself, and not see the downside that it has not been implemented, it has not been taken forward, and so on and so forth. All right. Now, what does it take? Again, the third point, ability to handle the unknown. I kind of called this out earlier. What you will be working on has not been worked upon before. Now, in that sense, there is nobody to go to help for. If people knew how to solve the problem, they won't come to the research team, because then they would have solved it. And the common example that I give for this, or usual example that I talk about when I'm speaking about this, is let's say you have to develop an application, right? And we all know how to build an application. You open up the ID, you start a new project, the structure gets created, you write a few web services, so on and so forth. Where's the research in this? It's not. And as a research lead, I make it a point that I don't take up problems like this, so that, because this is not new, everybody knows how to do it. There's no R&D in this. What is new is that, hey, if I have to write a web service, or I have to write a service rather, or a component, the core of it is, let's say you're solving an NLP problem, or you're solving a machine learning problem, or something else, or a distributed computing problem. You're solving a really, really tricky threading problem, right? For us, from a research team perspective, our problem area is that tiny bit, and I'm calling it tiny. It may be really, really complex and may take us months to solve. But from a research point of view, that is a problem scope of what we want to do, and how we want to do it is what we go after. The ancillary, or the pre-steps and the post-steps of the application, or publishing the web service, we don't even take it up. So now all the other things are known, but nobody knows how to write that multi-threaded component, or that the NLP component, or whatever that tricky part is. And that is where the point is that there is no one to go to for help. It's only you, your knowledge, your ability to research, your ability to go under the hood and solve the problem. And these are table stakes. Now, as you can imagine, what I mean to say by table stakes is that, and I've worked with product teams, in product teams as well in my career, and I've seen that happen. I remember one time we had this application, it was an enterprise J2E application. It's a little while ago, about 10 years ago, and we used to run the application on WebLogic, BEA WebLogic back then, which was the application server. Now, this was a product, and along came a customer who said that, hey, we use WebSphere, IBM WebSphere, as our application server in our company. Can your product run on WebSphere? So our initial reaction was obviously it doesn't. Now, somebody in the team said, hey, I will set up WebSphere and I will try to deploy our enterprise application. And it was an EAR file back then. And try to see if it works. If it doesn't, we will fix it. We will make it work on WebSphere, right? Instead of WebLogic. And that was a big thing. It was something that was well applauded. It was recognized, a big deal for somebody in the engineering team to do that. In the research team, that's not a big deal, because those things are table stakes. Picking up new tech, or picking up a different software, or a way of solving the problem is what we have to do on a day-to-day basis. So can you handle the unknown, right? Something that you've not done before, and then make it work. And then make it work is not just on the surface. Can you go under the hood? So if I were to extend this problem, let's say the application started running on WebLogic, right? But then it is running WebSphere. It was already running on WebLogic. the speed or the performance that you're getting in WebLogic, you're not getting in WebSphere. Can you go under the hood? Can you figure out what's happening? Why is it slow? Why is it running out of memory? Is there a CPU hog somewhere? Can you go under the hood to figure out what is really causing that slowness or that problem that you're encountering while you don't encounter it in WebLogic? And these are examples of what I'm telling you, but this is what realistically it is. Also, the example that I spoke about Elasticsearch earlier, right? When we were solving that problem, while we solved the business problem, we realized that this should go into the core of the Elasticsearch engine. And we actually downloaded the entire source code. So we forked the repo of Elasticsearch, and then we made changes to the core of the engine and did a contribution, right? So do you have the capability? Do you have the patience and intensity to open things up and literally operate on them, and then see if you can make a material change, not for just yourself, for everybody else as well. Last point here is I'm a Java person, I can't do .NET. You're in the wrong space. Trust me, there is no I can't do this or I can't do that in the research team. And I'm pretty much speaking about the way I run the team or the way the team is structured here. But I think this generally applies. The whole problem with research is that it is something that you have not done before. So invariably, if not today, tomorrow, you will run into a situation where you have to handle something which you have not done before, and you have to take it up. Another classical example, this happened in the team, and I'm giving you a real example. We were given a problem to solve. We started analyzing, and it was an assumption that, and all the guys in the team were Java folks, so they were experts at Java. And we started looking at how to address the problem. And then during one of the conversations, it just so happened, and it was probably a false assumption, but we had assumed that the target application would be Java. It came out that, hey, the target application is .NET, and we are not writing a Java library. We have to write a .NET library. A DLL has to be given out so that it can be consumed by the target application. And now none of the guys in the team knew Java, .NET. And when I said new, in the sense, they were not experts in .NET. However, one person in the team said, Piyush, I will pick up .NET, and how difficult will it be? I think I should be able to, spend, say, about 1 to 2 weeks, figure out how things work in that. And then, so ask for an extension of, 15 days, which I'll take to learn the language and learn the platform. And then rest should be good. So I did that, and he went ahead and he picked up .NET, and lo and behold, 15 days later, he started coding in .NET, and we were able to deliver what we were supposed to deliver. So I think wonderful example of having the right attitude and the approach. Because if and this is a simple example, right? I could have gone back to the stakeholder and said, look, we will not be able to do it. But how many times can you do it? If this becomes a habit, 90% of the work that comes to us is something that we don't know or we have not worked upon, right? I'll be saying this most of the time, and the research team can pack up its bag and go home. But this is a very, very important aspect that you must have. That pick up the unknown, pick up something you've not done before. Don't be afraid of it. I just take it as an opportunity to learn and further yourself and further the team. Obviously, the more you can do, the better it is. Okay. And I think this is pretty much the kind of a last slide. I have spoken quite a bit, but as I mentioned, that it looks pretty exciting, pretty glamorous from the outside, but is it really? And all the things that I've been calling out earlier, it's a challenging space. It's a challenging space because, as I explained, I spoke about, it is stuff that you have not done before. So you don't know whether what you're doing, what you're trying, is going to work out or not. You don't know if it will work out. Will it work out in the same way that you expect it to work out, right? You may run into performance issues. You may run into scalability issues. You may run into challenges which are completely unknown. In fact, and I won't take the name of this product, but we were working on this in-memory database, and it was a very, very tricky problem to solve. And we were able to solve it using that product, and we were really happy, right? We were like, this is amazing. This product is really, really cool. What happened was that while the what we were doing on our laptop worked beautifully, the minute we deployed it onto the server and we ran a really large query on it, it just the response just won't come. We were like waiting, and I remember after 8 minutes we see a error on the command line console, which says out of memory error, and the system crashes. And we were baffled because hey, this was working beautifully on the laptop. We had committed to our stakeholder that we have a solution, and now we realize that this is not working. Maybe we were premature. We were too eager to say that it has worked. What we realized that was in a real scenario with tons and tons of data. Obviously, laptop was a test bed, if you can imagine. Didn't have that much of data and all of that stuff. In the real server setup, the product had a problem. And that was the product's problem, not the way we were querying it. And that internal out of memory is more than evident to say that the system was doing something which it shouldn't. And we couldn't solve the problem. And huge amount of frustration because we were back to square one. We did not have a solution. We had committed to the end user that, hey, we have solved your problem. Big problem. So you will run into these situations more often than not. Obviously, to complete this story, we pivoted and we actually switched over to Elasticsearch, and I could tie it back to the work that we did on Elasticsearch after that. So we were finally able to give a solution, obviously not with the intended product that was initially asked, but with an alternative product. And obviously, we fed our findings to the product team, saying that, hey guys, your solution runs into a problem in this particular scenario when it is run in this way. And they acknowledged. They said, yes, we see what's happening here. And they probably went back and fixed it, obviously. But multiple things happened there. So the point here is, as an engineer, as a research engineer, can you handle this kind of a situation, right? It will be very challenging. It'll be difficult to manage at times, but can you stick to the guns and keep on delivering? Now, it is super exciting when you get things to work. Numerous examples, everything that I showed you, I spoke about. Whenever we have had success, it's a cause for celebration because n number of things. As I said, it is something new. It has not been done before. And when I say not been done before, I'm not talking of not been done before anywhere in the world. It is in your organization, in your company, in your group, in your teams, because that is why it came to the research team. So when you solve such a problem, which is generally a tricky or a difficult problem to solve, the sense of elation, the sense of achievement is super high, and it's really exciting to get that done. Obviously, it adds to your own technical acumen, if you will. It makes you a better engineer. I strongly believe that. There is a caveat there as well, though. Research team has the problem of making you a jack of all trades and master of none, and you have to guard against that. In the sense that we move, and you saw that right on the slide that I showed, we have worked through so many technology areas. It can be a boon or a bane. It can be boon because the exposure that you will get working in a team like this to the amount of technology is phenomenal. Right, we move from blockchain to Hadoop to AI to you name it, all the buzzwords, fancy words we have played around with the last 5 to 6 years. But then the question becomes, do I know all of these little bit, or am I an expert in one or two of them? I always advise engineers, young people who are looking to get into this space, that you must find your true calling. You must find at least one or two technology areas that you can ramble off in your sleep, right? You should know in and out of one or two technology areas, and you should be the go-to person. Whenever that technical area is talked about, your name should come up in that discussion. Hey, go talk to Piyush about this, or go talk to Piyush about that, because he knows that best, right? And that's where your value is. Because I think if you can master one or two areas in those ways, you would have gone through the rigors of what it takes to be a research person, and then you can take up anything, and you can play around with 20 technologies and know a little bit about all 20 of them, and come need be, you can dig deep in any one of those 20 or whatever you're doing, and go to that depth and master that as well. But very, very important, it takes a lot of patience, it takes a lot of effort, and that effort will be fraught with frustrations and failures, a lot of failures. A lot of times things just won't work, despite you trying to do what you want to do, how you want to do, but you will see that a lot of stuff will probably not work out the way you want it to work. Last but not the least, research is it is a challenging space. It's not an easy space to work in. The example that I wanted to finish off was with I've had great architects, and when I say great in sense, really really strong technology folks join the team, and after a while they find that, hey, they can't handle this start stop, right? We started something today, 5 days later we stop it, we move on to something else. That something else is sometimes in the same space, sometimes in a different space, sometimes completely different problem, different technology. Too much, right? Overwhelming. Couldn't handle it. Versus the person, he or she is really really good in, let's say, Java enterprise architecture or Java architecture in general, right? As a software architect, and he would rather be in that space where you are handling release after release. You're focusing on the technology, you know the technology, you're good at it, and you're able to deliver what you want to do. So when you're looking at it as a career option, think of what is it that you want to do with your career. Think of how will it satisfy your own intellectual needs, right? Do you have it in you? Do you want to get into the space to be playing around with tech? As I said, from the outside, it may look really, really glamorous. It is, but it's very challenging. It's not an easy space to be in. Also, there is no harm in saying that, hey, this is not my cup of tea, which has happened. Again, the example that I was kind of mentioning, I had this really wonderful architect join the team, super techie, new Java, J2E, like anything in and out. You could talk to him for hours without him blinking, and he would have all the answers. But 2 months into the team, and he said, Piyush, I'm not able to, I'm not enjoying this, which is fine. And I think that is good, right? He knows his true calling. He knows what he wants to do and what is he good at. So play to your strengths is the message that I'm trying to pass here. Um, if you want to jump into research and innovation, everything that I've spoken before will have a role to play. You will have to address those at one point or the other, and and they will serve you well. Last but not the least, keep in mind that the research mindset will requires one other thing, which is that you may not always get the right answer. You will get answers which make sense, or sometimes they don't even make sense, but you're getting some outcome and all of that stuff. So again, be patient with that, right? It's a thought process. Can you think differently, and can you think out of the box? And I mean literally, because you're trying to solve a problem that you don't know how to solve, right? You're looking into something which is an unknown. So that approach towards addressing the problem, towards going under the hood, towards looking at alternative ways to solving the problem is very very key. This is in contrast to the regular, and when I say, I don't mean regular in the negative sense, but I mean as a software engineer, let's say you guys, Java well, or Python well, or .NET well, right? You're part of a product team or a software engineering team. Business requirements come in. We know we have to create this, web front end. We have to create a middleware and some database stuff, and we get down to it, right? Yes, the problem statement will vary from use case to use case, but you know how to create the web service, you know how to create the front end, and you're able to do that very nicely. Versus in this case, you don't know what you're going to create. Yes, you have an overarching idea, you have a thought of how to go about it, but what form or shape it will actually take in the long run is an unknown. So how do you approach that, right? What's your thought process towards that thing? That is another key aspect that I would urge all of you to pay attention to, and take it forward from there. Okay, now with that, I come to the end of my session, and I would be happy to take questions from the audience. Let me jump back to the comments piece. Okay, I'm going to scroll up and let's see. Okay, going through applied research. What is the word? Okay, word sense disambiguation. I will, Ruchi has asked this question, what is word sense disambiguation? Just to give you a quick example, bank. The word bank can mean two things: a bank, a finance entity, or bank as a bank of the river, right? So Bank of Baroda versus Bank of Narmada. We actually created an algorithm which would disambiguate based on the context of the document and tell you what you're referring to, right? So this is what was done. This patent is now, I believe, it is available publicly. It is still awaiting grant, but it is available. If you search for it, you should be able to find it on the internet. It is available for search. What about privacy and security? Look, I think this question comes up quite a bit. Privacy and security are no different in any field. When you have data, the way you would protect your application today is the way you would protect data in any scenario. Data at rest, data in transit. So we all talk of the website being HTTPS compliant. You're trying to address that the communication that's happening between the web and the server is secured. When data is at rest, it's residing in a data store. That could be a file system, that could be a database. Is it encrypted so that if somebody gets hold of it without being able to decrypt it, they are not able to read the data? So I think those concepts or those practices apply in any case, whether it is big data, whether it is any field. The other day I was talking about virtual assistants, and the same question came up, and my answer was pretty much the same. Even in the case of a virtual assistant, the underlying security principles do not change. They remain as it is. Okay. Mandeep, can 18 plus years HR professional move to research and analytics? I will not say no. Absolutely, you can. If your capability, it is a matter of what you're able to, what you bring to the table. I think it's about, as I said, have that one area where you are an expert at, right? When a topic comes up, and I can take my own example. I have, at least for a while, I had expertise in object-oriented programming, and I'm talking about 10-15 years ago. I used to write for various magazines and all. But in my organization, everybody knew that I had an expertise in that area. So whenever object-oriented programming came up for discussion, my name would automatically get brought up, right? So can you bring that to the table? If you can, for sure. And then, as I said, move into other areas because you're able to do it. Okay, what can a consumer research person do to step up to this sector? What courses? Sabina Anand. So, Sabina, I would say that this session is more targeted towards engineers, if you will. And I won't claim that I know a lot about consumer research in that sense. I'm a techie myself. My career has revolved around technology. So the short answer is, as I just responded back to Mandeep, that in the space, if you have a research team which is doing consumer research, then obviously you're right there, right? For a consumer research person to move into technology research may be difficult, may not that be straightforward, and can be a challenge. Do you require technical qualifications, degrees? Question from Ruchi again. Well, it's a double-edged sword, Ruchi. I know that a lot of organizations in the interview process would ask you, can you write this algorithm? Can you write that algorithm? For me personally, it's the attitude and the ability of the person to think differently. I don't look for people who can solve algorithms. What I look for is, when I give a problem, how is the person thinking? How is the person approaching the solution? And if that meets the criteria, or that shows a thought process that the person is, has the ability to think differently, That's what really applies to for me in the field of research. So degrees are important. They obviously help you because you go through a formal process and you learn a lot more. But is that a mandatory criteria? Maybe, maybe not, depending on the organization. Okay. All right. Um, Does Optum invest in R&D to solve problems of depression? Oh, absolutely. We have health services. This is obviously my team is more focused on technology aspects, but yes, health-related research is definitely going on. We make, even if we don't do it ourselves, we partner with clinics, we partner with top-of-the-line health institutes to work on these problems where you have clinicians who are really driving this thing. And then taking this forward. But we do participate as and when it makes sense for us. Okay. Okay. I think there are a few other questions around job opportunities, internship options. So again, via this forum, it's very difficult for me to respond to that. But please feel free. This is a career fair. Please feel free to reach out, and I'm sure somebody will respond back to you whether some opportunities are available. But in the field of R&D, it'll obviously. How should I put it? So I think maybe I should have explained it, but I can talk about it now. It's a good question. See, research teams will never be large teams. You will always find research teams to be small. They're like ninja teams, if you will, or sharpshooter teams, whatever you want, or SWAT teams, right? These are really high-end technology experts who make it to research teams. So you have to be a cut above the rest. So folks, please don't think that I'm discouraging you. I'm telling you the facts, right? If you have, and this is from my personal experience, if you have 100 people out there, 1, 2, max 3 to 4% people are who will be able to meet the requirements or the criteria for a research engineer. It is a difficult space, and to that effect, we look at people who are cut above the rest. So you have to be an expert techie out of the box, right? You have, if you're a Java guy, you have to know how Java works. When I interview for a research engineer, I expect the person to know JVM. I expect the person to know how the GC works. I expect him to know what's happening under the hood, and that is not even the criteria. That is something that he or she should know, right? And then above that, I'm looking for that additional thought process and everything else that I explained to you, that flexibility, that adaptability, that emotional, not being attached to your work and all of that stuff. So opportunities are there, but you will find it a little bit of challenge. You will find it, it's not an easy space to be in. But hey, if you've got it, if you have that aptitude and attitude, why not? You should be able to make the cut. Okay. All right. I don't see anything else that I can respond to. Any other questions, folks? We have about 10 minutes left. All right, I think with no more questions coming in, I would like to thank you for joining in today. Hope the session was useful and gives you some insights into this area. As I mentioned, from my experience, it's something that everybody wants to do, but there are pitfalls and there are caveats. And what I've spoken about today will give you some sense of what it takes. And I wish you all the best. Um, and stay safe and take care. Thank you for joining.